Hello and welcome everybody. Today we will look how we can make a real image classifier using Tableau Prep and the Einstein platform services. And this is quite special because when you're using Tableau Prep, you are most of the time probably connecting to tabular data, rectangular data, tables. Today we will have a look how we can connect to what is called unstructured data and make use of these very neat APIs which are part of the Einstein platform services, which will help you to really empower everything you possibly will do with Tableau Prep. Now, first of all, what is image classification? Basically, you feed an image to an algorithm, and that algorithm will decide what is on the picture. So, in this little example here, it's very famous because when you learn or read about image classification on the internet, it's most of the time about an algorithm deciding whether something is a cat or a dog. Now, the first thing we need to know is that when you make these classifiers yourself, you would need to have a whole bunch of labeled photos, in this case of cats and dogs, in order to make this. Now, making these image classifiers, if you're not knowledgeable in R or Python, is not that hard. You can build it yourself, but it's a lot of work if you want to build a specific image classifier to have a good, decent library of labeled images to train on. So imagine you're not in a situation where you actually can build these image classifiers yourself. There is the Einstein platform services, which we will have a look into today. The Einstein platform services offers a range of APIs ready out of the box, which you can make use of in your apps, in your software, on your website, or in this specific case, in a Tableau Prep flow. And as I've mentioned, today we will have a look at how I can make use of this Einstein image classifier in order to feed images using Tableau Prep to the algorithm and get the actual Einstein image classification in our database. So if you want to make use of the Einstein platform services, you first need to sign up, of course. You can do that by going to einstein.ai. Once you've done that, you'll need to create your access token in order to make use of these APIs. In this case, we have already done that, and I'll now show you the use case we'll be looking into today. As you can see here, at Biztory, we do love food. Whenever we are eating during the day, we share that with our colleagues. Now, due to the fact we all have these very diverse backgrounds, it is not always clear what our colleagues are actually eating. So wouldn't it be nice that we could get help of Einstein to help us to predict what's on the actual picture? So what we have done is we created a Google form where everybody can upload their images of the food they are eating that day. The beautiful thing about is that Google form allows you to actually upload files. So in this case, all the food images are being uploaded, and the answer form actually gets the URLs to these images. These are the images that we will later on use in our prep flow to be scored by the food classifier of Einstein. Now, how does that work? Okay, the first thing we need to do, of course, is find a way to connect to this data in Tableau Prep. So let me go to Prep. So the first thing we did was make use of the Google connector in Tableau Prep. So as you can see here, we are loading all the uploaded images in Tableau Prep. We've got the timestamp when it got uploaded, and we also got the name of by whom it was uploaded. Now, what you will see in the Tableau Prep flow is that we have, I've created a calculated field because I need to link the images later on. So I subtracted the key here. Then secondly, the way the URLs are being stored in the Google form are not in the format that the API endpoint can deal with these URLs. So what we see here are the URLs, how they were captured by the Google form. And then secondly, we have the source column where we have adjusted the URL just a tiny bit so it can be fed to the API endpoint. Without going too much into details, we have just created a URL which contains the export equals download and then pasted the ID after it again. Now, the most important part of this flow, of course, is the little Python code we use here, because we use the Python code to feed the URLs to the Einstein APIs. Now, what is going on in the Python script? So first of all, we need to import two little packages. The first one is the requests one, which we will use to actually do the requests. And secondly, we import pandas to deal with the input data as a data frame, which is pretty standard in Tableau Prep. Then we have the output schema, which you always need to define when you're using Python with Tableau Prep. So what are we expecting back from the API endpoint? In the first case, of course, it's a label. We feed an image to the endpoint and we want the algorithm to decide what is on the image. So the label will contain the label, what the computer thinks that is on the image. Then the probability is the likeliness, let's say how sure the computer is about the label which is being attributed to that image. And then of course the source is the original URL which we still would need. Now, one very important thing to keep in mind is that there are multiple predictions taking place for each image. So if we feed one image to it, you will find multiple labels and multiple probabilities, of which the one with the highest probability is probably the one you want to go with. Then this little definition, we inserted our token. It's important to say here that we did not train a food image classifier. The food image classifier is a out-of-the-box pre-trained endpoint one can use in the Einstein offering. Then here we find the actual endpoint we are going to query. And then, of course, we expect some response being the actual probabilities and a label. If we don't get a label or a probability, sorry, if we don't get a label back, we want to have error, and we have set the probability to be 1. Then, of course, as always, all of this needs to be put in a beautiful data frame so it can be sent back to Tableau Prep. Okay, so in short, I am here connected to my Google form. I've done some rudimentary cleaning, and then I will let the Python script do its thing. So let's have a look at the output. This can take a moment. As you can see here, for every picture there is a query to the API endpoint. We see at first sight that all things are going well because we get a response of 200. And when that is done, we should be able to see the output. Okay, so we are done. Let's have a look what we've got now. Let me bring my source forward. I'm not interested in the key. But for example, all the URLs correspond with an image. So let me go for the first one. And the algorithm seems to detect ratatouille, ravioli, summer squash, omelette, and prosciutto. I don't know what all these things mean, but as mentioned, we also get the probabilities. Now, these probabilities are rather low, but as we will see, even though if the probability isn't 95%, the estimates of the algorithm are rather good. Let's check another one. Here we see eggplant being predicted, chicken parmesan, pizza, and mozzarella. Here we have an 87 probability. Here we have crab curry with a probability of 0.72. But bottom line, you see that for each image, we nicely get 5 probabilities back, which we can start working with in a later stage. Now I've joined it back to know from who the actual image was, but this step isn't very important. The most important thing we will do now is actually write it to our server so we can have a look how it looks into Tableau in Tableau Desktop. Okay, our Tableau prep flow has run and it has been published to our server. Now let's open Tableau Desktop and have a look at the dataset we're working with right here. Endpoint. Now one final time, so for each URL we have 5 labels and probabilities. What we have done here is we created a dashboard where we in the left have a parameter drop down where we can select the input images. So let me go ahead and just select one. So if everything goes right, here at the top right we see the original images being brought to the dashboard, making use of the web page object. Then for each selection we see the 5 labels. So in this case it's very obvious that he detects the CHURRO in the picture rather well. He's even 99% sure that it's a CHURRO. One thing to take in mind is that we do not do any kind of object detection here. The algorithm takes into account the image as a whole, because sometimes you might wonder, why doesn't he see that it's a coffee, for example? Well, without going into the details, probably the form, the characteristics of the CHURRO are way more discriminating for the whole picture as a whole, so that's why he goes for the CHURRO prediction. Let's take another one. We can definitely say some noodles are in the picture. Whether it's a noodle soup, I can't even really say. It might be, but once again, I select an image. The image gets loaded from Google. We see the 5 labels and we would need to go for the noodle soup as our best guess. Okay, one more. This is sushi. So the image clearly shows our sushi. The algorithm is 86% sure it is sushi, and I think it's safe to say that it's correct in this case. Now, if you're wondering how you would use this in practice, you of course would not make use of all the labels, but you would go with the guess of the highest probability, probably. Another one, a egg. Don't ask me how he sees whether it's boiled or not, but the most important thing here is that he sees it's an egg with a 57% probability. Okay, in summary, what we did today was show you how you can make use of the Einstein platform services, which are out-of-the-box AI-powered endpoints. It also has pre-trained models. Today we showed you how you can take this pre-trained model, being the image classifier, to Tableau Prep to be able to deal with unstructured data and let it actually predict label unseen images. In the next videos, we will also have a look how you can use the object detection, how you can make use of Einstein OCR. Now, what's the difference between object detection and image classification? In image classification, you just feed the actual image and you say what's on the picture. With object detection, you don't only say what is on the picture, but also where it is on the picture. Then thirdly, the OCR is also part of the Einstein vision. It's a very neat one. It allows us to detect or words or sentences on an image and then translate them back to actual data with the text. Something which could be very interesting in the context of scanning documents or detecting brands in specific images. Alright, thank you for watching and see you next time.